Hey you guys, this is Mr. Millings, and in this video we are going to learn how to calculate the frequency of a wave when the wavelength of that wave is known and the wave speed of that wave is known. So let's take a look at this problem right here. It says to find the frequency of a wave traveling 1.34 times 10 to the third meters per second if its wavelength is 4.44 times 10 to the negative 7th meters. So we have a wave here, and it looks like that the wave could be traveling in this direction right here with a speed or velocity of 1.34 times 10 to the third meters per second. What we also know about this wave is its wavelength. Its wavelength here, or lambda, equals 4.44 times 10 to the negative 7th meters. And what we're asked to figure out here is we are asked to figure out the frequency. We want to find F here in this formula. So we know that wavelength, or lambda, equals wave speed or velocity divided by the frequency of the wave. So we can use this little formula right here to figure out what the frequency of this wave is going to be. Let's jump right in and solve this problem. We know that wavelength, or lambda, equals velocity over frequency. And so in this problem, we want to solve for frequency. We want to get F all by itself on one side of that equal sign. So the first thing that we need to do is we need to get rid of this fraction right here. So let's go ahead and multiply both sides by F. If we multiply both sides by F, F now cancels. And now what we end up with is velocity equaling frequency times wavelength. But we're trying to figure out the frequency of this wave, so we have to now divide both sides by wavelength, or lambda. And so now wavelength is going to cancel from the right hand side, and so the formula that we're going to use to solve this problem is frequency equaling velocity, or wave speed, divided by wavelength. And so now that we have our formula to figure out what the frequency of this wave is, we just need to plug in these two variables here. So what is the wave speed or velocity of this wave? It's 1.34 times 10 to the third meters per second. And what is the wavelength of our wave? It tells us right here it's 4.44 times 10 to the negative 7th meters. And so now we can just plug this into our calculator, and we're going to take 1.34 times 10 to the third, and we're going to divide this by 4.44 times 10 to the negative 7th, and we're going to end up with 3.02 times 10 to the 9th power. What unit is left over? Well, meters here and meters here are going to cancel, leaving us with S to the negative 1 power. And this S to the negative 1 power just means that seconds, or S, is in the denominator here. And if we wanted to, we can also say that this is equal to 3.02 times 10 to the 9th hertz. Hertz and S to the negative 1 are going to be used interchangeably. So we just figured out the frequency of this wave here is 3.02 times 10 to the 9th hertz, when we knew its wavelength was this and we knew its wave speed was this. So if you like what you see, go ahead and click that little bomb in the bottom right hand corner, and that will subscribe you to my channel. And feel free to leave any comments or questions in the comment section down below, and I really hope you guys found this helpful.